the history of biomass in the population in previous years. And with an estimate in our current year, we can use it to provide management advice, such as a TAC. So these trajectories show what an ideal, how an ideal assessment should behave. So in the pink line, we have biomass estimates up to 1989. We can give the catch advice from there. In the next year, we'll run the model again. The model picks up where 1989 model left off into 1990. So we have an updated estimate, and so on and so forth forward in time. Unfortunately, what tends to happen is that we have, when we rerun the model, the estimates all diverge from one another. So as we add more data to the model, the biomass estimates all diverge, and you don't have a consistent set of estimates of what the historical biomass was. So this has been an example from Pacific halibut, which is chronicled well in this Stewart and Martell paper in Fisheries Research. So this divergence is what we call a retrospective pattern, because as we add more data, the estimates move higher and higher up. This happens because we don't just project an old model forward in time, but we actually re-estimate all the parameters that determine the stock size. So how do we evaluate a retrospective pattern? We can't look forward in time if we have data from the most recent year. Instead, what we do is we peel away data from our current model, looking back in time. So let's say we have our assessment in orange up to 1994. Then we can take a year, the 1994 data away, get the yellow line, we take 2 years data away, and so on and so forth, up to 5 years here. So from the deviations of the terminal biomass estimates, we can use a statistic called Mohm's rho, which calculates the relative discrepancy between the terminal year in the retrospective ones versus biomass in the corresponding year in our full model. And the sign of Mohm's rho gives the direction of the pattern. So this is a negative Mohm's rho, which tells you that you get a bigger stock as the as years are added. And this is an example of a positive Mohm's rho, where we're getting more pessimistic. We're estimating a smaller stock with more data. And the magnitude of Mohm's rho also tells you how bad the pattern is. So what's the problem with the retrospective patterns? We usually base our catch advice from the stock assessments based on the terminal biomass values here, which are in these points. Now, if we look at the full model in the 1994, we would say that over the past 5 years that biomass has been decreasing, it's been declining. But in hindsight, when we've been using these assessments in the past 5 years, we'll see that the estimates of the estimates for which we use the catch advice have actually been increasing. So let's take a look at a hypothetical harvest control rule where we use that biomass estimate and we set the advice on a fixed target harvest rate. So if you use these values, what you actually get is that the catch advice has actually been increasing over time, despite seeing a decrease in the trend in the biomass. So this leads to a very unintuitive behavior in how the catch advice is provisioned relative to what trends you've been seeing in the stock assessment. And in the bottom cell here, you can see the opposite situation where even though the biomass has been increasing, your catch advice has been relatively stable. So here's kind of what we know about retrospective patterns so far, because it doesn't happen just for Pacific halibut, it happens for many assessments out there. Major patterns are probably indicative of some sort of model misspecification. So there's something happening out there that we're not capturing in the model. And as a result of that, the retrospective pattern is a symptom of us missing out on some important dynamic. Unfortunately, retrospective patterns don't reveal the source of the pattern, nor do they reveal the direction of the bias, meaning the pattern that we see doesn't actually tell you whether you're systematically overestimating or underestimating the biomass, because you don't know the true state of nature. There are multiple potential fixes that can get rid of these trends, but unfortunately, there's few data to inform which of these fixes we should go with. Because if we had the data, we would have incorporated into our base model in the first place, and we wouldn't have this issue. And importantly, from the management aspect, different ways of fixing the model will generate different catch advice. So how do we proceed from there? One way would be just to ignore the problem and hope that the issue goes away. That's probably wishful thinking. Another method that has been tried in some places is to do a row adjustment based on your biomass estimate. So looking back at the Pacific halibut example, if we know that with the retrospective peels that we're getting pessimistic outlook in the biomass forward in time, then in our most recent value, in most recent assessment, we can downward adjust based on Mohm's row in acknowledgement that this retrospective pattern is likely to continue in the future. We can try fixing the model, but as I said in the previous slide, there's many ways to fix it, and so which way do you go with? And even if you pick one way of fixing it, such as catch, you think that there's some issue with the catch reporting, when did that catch reporting issue arise? So this figure shows your SSB Mohm's row relative to the catch multiplier, which is basically telling you how much higher the catch had to be. And to eliminate Mohm's row, you have to pick a year as to when the missing catches started. And as you can see, you can start it in 3 different years. And the value of the catch multiplier that gets you 0 Mohm's row to eliminate the retrospective patterns changes. So which one do you pick? Finally, the last way is called, that I call model average, means that you just don't pick one model, you just take the average of the results of the 3 and provide your catch advice that way. So the focus of my talk will be to try to answer, to develop a way that allows us to answer the question that I posed at the top of the slide. Which method should we use to provide the catch advice? So the framework that I mentioned in that title slide is of how to evaluate the consequences and robustness to retrospective patterns is to develop those alternative operating models that can explain the retrospectives. They're not And I'm not trying to say anything but their plausibility of these alternative scenarios. They're what if scenarios. What if these were true? What if these are the things that are happening that we're not capturing in our models and are subsequently generating these retrospectives? From these operator models, we can apply the different approaches for providing catch advice using closed loop simulation. And we can evaluate the outcomes in the operating models with respect to management outcomes. For example, for the probability of exceeding limit reference points and evaluating trade-offs with short-term catches. We know that the model is going to be biased in the sense that the assessment models are going to have different estimates of biomass compared to the operating models. But the focus here is to say, does that matter when we're looking at providing catch advice and looking at what happens to the stock in the operating model? And finally, if we adopt one of these methods for providing catch advice, can we can generate simulated projections of the data. And so we want to see if any of those data indicators or model behavior could reveal what's causing the retrospectives in the real world. So for my case study, I'm looking at New England groundfish. It's an area where there's been a lot of retrospective patterns in many of the assessments. So this is a table showing many of the VPA and age-structured model, this statistical catch age, and showing the Mons row for 2 years of assessments in 2017 and 2019. In terms of like a rule of thumb for what a good retrospective Mons row looks like, the literature suggests a rule of thumb of less than 0.2. And you can see here that many of these are much, much larger than that 0.2. And I think these are the ones that just pass peer review as well. So I looked at 2 case studies for this talk, the paper. The first is could be cod in the Gulf of Maine, and the second one is going to be pollock. So for cod, there's been a persistent overfishing history occurring for the most recent decades. Part of it is related to the continued retrospective patterns seen in the assessments, because catch advice is given in 1 year, and then a few years later, we see that the corresponding F with that catch advice is found in hindsight to be much higher than it should have been. So part of the reason for this overfishing history is this behavior that we've been seeing in this talk today. Currently, there's 2 benchmark assessments that are presented for management. The first one assumes that the natural mortality has been 0.2. And as you can see here, it generates a Mons row about 0.8, which is quite large. An alternative model that's also presented is the MRAMP model, which assumes that the M has increased to 0.4 during the 90s, and this drastically reduces Mons row. There's been tagging studies that suggest this higher value of M in the range of 0.4, although when we look at max age, the maximum age observed in the stock, that value corresponds better with 0.2. So we have different lines of evidence to suggest different values of M, and those interact with the retrospective behavior in the assessments. Finally, a third thing that may be happening in the Gulf of Maine cod, well, in the New England fishery, is that there's been a lot of discussions about catch underreporting. So there, in the New England groundfish fishery, there isn't 100% observer coverage and there are economic incentives to misreport catches, which is described well here in this King and Sutton paper. So going through the framework of the first step is to develop alternative operating models, and I conditioned the OMs in order, based on those two benchmark assessments, to try to eliminate the retrospective patterns using time-varying dynamics. So the first one is to look at what if the cause is miss and catch. So in order to do that, one scenario is that the catch reporting rate was just 40% since 2009 with M of 0.2. I have an increased M, which says that all the retrospective patterns are a result of M. So that to get that scenario, I increased M to 0.45. And then the third scenario incorporates both. So 80% reporting rate with an M of 0.4 since 2004. And those values continue into the future. Next, I'll do the closed loop simulation and describe in a couple slides how that works. So when we think of a management cycle, we start with an exploited fish stock. We collect fishery and survey data in which we can fit a assessment model and apply a harvest control rule. Those steps are usually referred to as a management procedure. And then we can implement the catch advice, and the cycle repeats over time. Closed loop simulation is a flight simulator of the management cycle. So to represent the stock, we have an operating model, which can include those alternative states of nature that I presented previously. We can simulate fishery and survey data, and then elsewhere in the simulation, we can fit the model and apply the harvest control rule just like we do in real life. And the assessment model only sees the data, not the operating model. We can implement the catch advice, and then we can project the OM forward in time in order to continue the simulation. So here are the details of the MPs for cod. I can either fit an MO2 or the MRAMP assessment in each of the three OMs, and then calculate the Mohs row. I apply the catch advice that's being used in the New England system, which is to fish at 75% of F40, which is the proxy for FMSY, and use BREF as the basis for the TAC. If we're not applying Rho's adjustment, the BREF is just the vulnerable biomass estimated in the assessment. If we apply the Rho adjustment, then BREF it has this adjustment factor based on the calculated retrospectives for that model. I can also do some model averaging, which is a form which is more closely aligned with how cod is managed today, which is to take just the average from MO2 and MRAMP in lieu of Rho adjustment. So we have 5 MPs that are named with RA, describing Rho adjustment. And I can compare that to perfect management of fishing at 75% FMSY. And importantly here, in the simulations, I said that the reported future catch was equal to the TAC, but the true catch was subject to the reporting rate. So it's saying that the MPs are naive to the reporting issues. So next we can look at the results of applying these MPs every 3 years for 50 years into the future. So this is showing what the spawning biomass in the operating model looks like, where the rows give you the different operating models, and the columns give you the different MPs. Oh, and the two lines are indicating 50% and 100% of PMSY. So the first question is, how should we choose between MO2 and MRAMP? Look at the first and third columns. You can see that the performance is really driven by what the true state of nature is. But even then, especially in the MO2 MP, but yeah, even then, if we look at MRAMP, the performance seems to be better. We have MRAMP generates lower F in the operating model, which allows the stock biomass to recover in much better state compared to MO2. Although the catch trade-off isn't as large as you would think it is, because the stock in MRAMP is in a much better state. Next question is whether we should row adjust or not. So we can look at the first two columns between each other and then the third and fourth columns within each other. And we can see that the row adjustment is more precautionary in most cases. We see that the biomass is higher in the RA's MPs because the adjustment in most cases is downward, so your catches are lower, which allows you to reduce the F on the stocks. And finally, with the model averaging MP in the fifth column, it's behaving probably in between what the row adjustment and the MRAMP models is doing. And so that is probably, in terms of ranking performance, the other two methods seem to perform better compared to model averaging in this stock. In terms of indicators, can indicators help you detect the true underlying state of nature? So what I did here is take a look at the simulated future Mon's row retrospective behavior in the assessment model and compared it with use a second indicator, which was the proportion mature in the age comps of the surveys. So that if there's more mature animals, that is indicative of a healthier stock. So in these in the scatter plot, showing the simulated values in the closed loop projections, the color indicates the operating model. I can use a linear discriminant analysis to try to classify the OM based on these two indicators, as well as year as an interaction effect, because we think that as the stock is rebuilding, how these indicators behave is likely to change. From the black line, I can give a 50% contour line to try to differentiate between the missing catch OM, so trying to separate what happens, so the space of the indicators that tell you be indicative of a missing catch scenario versus some sort of M scenario in the blue and green. And you can see that it's much more difficult to separate the blue and green OMs from the missing catch OMs. And finally, we can do some cross-validation of the LDA using a leave one out analysis to see how well the model can predict one of the values, one of the values that you take out. So we want this prediction skill to be high in order to trust it. So we have a lot of numbers here, but the takeaway message here is that these three, and from these three MPs, you can see that the prediction skill is higher, indicating that if we use these MPs, we can see better separation among the OMs with respect to our indicators. Whereas with the MO2 and the model averaging MPs, these prediction skill values are much lower, so they're less than 50% in terms of cross-validation. I'll just quickly go through the slides for Hunyh Pollock, which is intended to provide contrast from COD. Same situation here. We have two benchmark assessments. So from the base model, the survey selectivity is assumed to be dome-shaped, and that's from observations that odor fish can outswim the survey trawls. And since the fleet selectivity is also dome-shaped, then it means that we're modeling biomass that's not observed anywhere. So the flat cell model is a sensitivity run that says that the survey selectivity is flat-topped, although the retrospective pattern is worse in that model. I looked at different causes for the retrospective bias here. One was looking at survey selectivity. I was sending it to much lower than what it is in for the H9s. The selectivity is a lot lower than what it is in the base model. And then the other two OMs are to look at survey weighting. So I increased the lambdas in the likelihood for the surveys. It's a bit nebulous as to what the mechanism behind survey weighting, out there, but it's basically saying that we have a biased estimate model in the base and flat cell, and the stock is a little bit bigger or a little bit lower than what it actually is. In terms of running the closed loop simulation here, the story is pretty straightforward. All these lines are above BMSY, so your stock is in pretty good shape. There's poor predictive skill in general for the indicators, but then the question is, what's the problem here? Because the stock is in pretty good shape, as I showed in the previous slide. So to wrap things up, if you were to do these analyses for Hunyh and Pollock, you would say that performance relative to BMSY of these different approaches are dependent on the state of nature. But among the current choice of MPs that you have here, you could rank, MRAMP is preferable over MO2 and the model averaging, and the model adjustment is preferable over not. You can get better contrast in some of the indicators for the MPs that perform well. But among the three OMs, it's easy to separate the missing catch OM from the increased, the ones with the increased M. And generally, you'll probably have better ability to use the indicators if you have bigger contrast amongst your OMs as well. And for Pollock, all the approaches here seem to be pretty robust in terms of the MSY. So just to give a summary of the limits and the benefits of the approach, I'll say here that I didn't include all the potential scenarios for the two stocks in this analysis. So a lot of other things that could be going on, like juvenile cod mortality, that's been proposed for cod, and that would be a selectivity issue in terms of mortality. And I used the survey selectivity issues for Pollock to contrast it with cod, but you can remove the retrospective using M and missing catch for Pollock as well. We do need to consider how the cause of the retros affect the future productivity in the operating models, because those will affect the indicators as well as how the stock will respond. When we look at just an assessment approach, the biomass estimates may not be affected by where the missing fish come from in the cod example. So whether it's missing catches or high M, you just know that the mortality is much higher than what is otherwise assumed. But if we're going to do the analysis in closed loop simulation, they have, those two causes have different implications on what the future productivity is going to be. And as I said, indicator performance is dependent on contrast amongst OMs. But the benefits of the approach is to recast the problem in terms of management objectives and robustness to meeting those management objectives. So it's not just a matter of model misspecification. I'm not saying that's not important, but this is another way to look at the problem and to see if the retrospectives matter. And that can prioritize, your data and research efforts. And the framework, it's not a finished analysis. You don't just do it once. You can always reevaluate if, for example, the cause of the retrospective stop. For example, the New England Fishery Management Council just passed an amendment adopting 100% monitoring of the target. And analyses elsewhere have suggested that this does improve management performance. So this is different from what I presented today, us being naive to catch underreporting and that it continues. But we can always update this scenario, run additional scenarios where the underreporting stops. So with that, I can take any questions from here. Thank you.
Thank you very much, Quang. And Tom, did you want to comment on this?
Yeah, sure. I mean, I just wrote in the chat. I mean, the idea here is that basically there is an almost insurmountable scientific endeavor to be involved in trying to think of all the ways in which problems in our assessments could be due to parameters, external influences, covariates, you name it. The problem is we essentially don't have a manipulative experiment to know definitively which of those things it's true. So we're always going to have this problem. We're always going to have multiple hypotheses. The way this framework deals with that is it says, let's formalize those hypotheses into states of nature and operating models. And let's see first, does our status quo management actually perform badly? Like, is it really a problem in the first instance? Let's not bicker about whether it's, seals, volcanoes, whatever it's going to be that people are proposing. Does it matter? Then you say, okay, if it does matter, do we need to develop a new management procedure that will navigate these situations better? And if you can't do that, are there indicators, are there data you can monitor to tell you, actually, if you're going to go ahead with this, these are the problematic data that are associated with the problematic state of nature. So the idea is to make forward progress without getting into this is my pet scientific theory, which has started to characterize a lot of stock assessment processes as time-varying dynamics emerge, become more apparent. So this is just a way of using operating models to make progress, basically. Thanks.
Yeah, Carl. Unmute yourself, Carl. You can't do that?
Okay. I'm unmuted. Do you hear me?
Yes.
Yep.
I found it interesting, Quang, that you talk about model misspecification in the biology side of the model. But a stock assessment model actually has two fundamental submodels, a state dynamics model and an observation model. And the worst retrospective biases that I've seen actually were because of misspecification of the observation model, in particular hyperstability in survey indices that causes downward bias in Fs and overestimation of abundance. Why didn't you explore any hypotheses about problems on that part of your model structure?
I guess just looking at the question for cod, I mean, salmon, the missing catches are the big players. Is what people are trying to grapple with. So that's what I started off with. In terms of the surveys for cod, I think they do a pretty good evaluation of the spatial range of the stock. So there's been a lot of range contraction, obviously, for cod as the stock has been, I guess, fished down, or however the stock has been driven down. But I think there's pretty good confidence that the survey's been adequate in indexing the stock. So we can see that there's been big decreases in the surveys. And so, at this point, it's almost a question is how they could decrease even further. Like, if anything, it'd be, if you look at hyperdepletion, I mean, hyperstability, I mean, we've seen huge decreases in the surveys already.
Just as Murdoch here, just to follow up on that, one issue is that if the survey doesn't have sufficient coverage, there could be some stock biomass that's part of the breeding stock that's outside of the survey area. So we know, like from other stocks, that you can actually see hyperdepletion in a particular survey area, and if it's incomplete, then you're going to obviously you're going to get a pronounced overdepletion in your data. So it's a hypothesis you can't really test, because if there's some stock biomass outside of the survey area that's not really changing as much, then your survey indices will by definition give hyperdepletion. So even if it's a fishery independent survey, you're not protected, and that's mainly because the range of the survey will not. If it's insufficient, you're going to be on the other side of things. If you're actually in the area of high density, then you're going to see hyperstability. So surveys, fishery independent surveys, are actually pretty nastily prone to either hyperdepletion or hyperstability, and you can't say as an analyst whether or not the survey is covering all. Yeah, you need to have tagging studies and other indications to try to get at that. So I think that was that's a point that's really hard to address in terms of assertion about hyperstability or hyperdepletion.
I guess the question there, Murdoch, would be to look at the stock structure of cod in New England. So we have the Gulf of Maine stock, as well as the Georges Bank, which has even worse retrospective patterns. And I think they're being managed, that stock is being managed using an index-based rule because you can't get an assessment past peer review. But if you think, that the two stocks are more connected than it is, then we'd have to consider what the best stock structure is, whether to consider it as one unit or separate it as two.
Yeah, so this is an issue with this type of analysis. Tom seemed to indicate that it's a good way forward to develop operating models, but your indication of robustness is only pertinent to the operating models that you have. And if you're missing the let's say operating models that are say closer to the truth, then you could say, oh yeah, it's robust, but only to those two operating models or three that you have, like catch under reporting or changes in M. Like you had mentioned, maybe changes in juvenile mortality rates. That's analogous to changes in stock productivity, and that's another thing that's commonly found, changes in let's say the A parameter or the carrying capacity. And so there are a lot of hypotheses out there that could operate quite differently from changes in, let's say, M, or changes in let's say catch reporting and so on. And so it looks like to have a more general test of this, you'd have to assemble quite a wide range of different sources of retrospective patterns. We saw in Atlantic bluefin tuna, a huge mistake in the VBA code that was there for about 15 years that drove massive retrospective patterns in the stock assessments. And those weren't detected for 15 years. But they knew in the end what it was, because when they corrected that retrospective mistake, or that coding error, those retrospective patterns vanished.
I guess, yeah, coding errors is not a compelling story, but obviously we want to consider some suitable number of operating models with which to test robustness. I presented 3 here, but of course that can be a bit larger. That contrasts with the assessment framework where we have to pick a best model. And so this allows you to look at different hypotheses.
Tom first and then Carl.
Yeah, I mean, look, Murdoch's point about there might be unknown unknowns or other things that we haven't covered that would cause, but of course, I mean, no one is claiming this is somehow comprehensive. I think the way to focus on this is to be more pragmatic, is to say we actually have a management situation. This is real. These stocks are really disputed. The stock assessments are really problematic. They can't make forward progress, and they have these principal axes in which they cannot find agreement on what's causing these retrospective problems. I mean, this is a real situation. This isn't hypothetical, and this was a way of getting through the situation we had. The one you're describing is a more general philosophical point, which is that there's a whole range of different scenarios that can cause retrospectives, and if you want to be more confident, you can gain confidence by increasing more states of nature. Totally agree. It's just that these two case studies you've seen presented here were real live problems where we're trying to solve the problem at hand and not the broader philosophical issue.
Carl. Unmute.
This is bullshit to be controlling that mute system. Why don't you just stop doing that? Anyway.
Everyone should be allowed to unmute themselves. There is no control.
You do not want to ignore programming errors. The single most widely used stock assessment software in Eastern North America was ADAPT for many, many years. Basically, the VPA developed in Canada. It had a catastrophic bug, and that bug wasn't really discovered until an NRC review generated a whole bunch of fake data sets and discovered that ADAPT, this most widely used software anywhere in fisheries, wasn't working right. It's a continuing issue, and it actually is an argument for trying to use simpler models whenever possible, where those kind of bugs are least likely to occur. But I want to bring up again the business that a stock assessment has two kinds of models in it, dynamics and observation, and you mustn't favor one or the other in choosing the set of alternative hypotheses that you're going to entertain for explaining retrospective patterns. The hypothesis set has to be at least that wide.
Duly noted.
Shame on you. These poor Quang.
Robin, did you have a comment?
Robin, you're still muted. Try to unmute yourself. You should be able to. There you go.
Can you hear me now?
Yeah. Good.
Yeah, there's all kinds of messages coming up about who can unmute me. Yeah, I was just going to say there's a bit of literature out there, and I know that the DLM tool team, Tom's team, promote it as well, of using reference and robustness sets of operating models, where experts agree on perhaps the most plausible and most important sets of OMs to be put into the reference set, and then a wide range of other possibly less plausible, but possibly important operating models are considered in a robustness set. And I think this is a really good way of exploring robustness. And how you deal with the results from the robustness and the reference set is, you know, it depends on the case. For groundfish in British Columbia for data limited species, we just worked on a framework with Quang and Tom using DLM tool where, you know, we came up with a system for dealing with results from the reference set and then how we dealt with the results from the robustness set, which I think is a good way of approaching some of these problems that we're talking about.
Yeah, I think maybe in this case, with the New England groundfish examples, you know, trying to find the delineation between what is reference and what is a robustness OM, you know, if you were to go that route. You know, for some of these things, it's some of the OMs, there's data, you know, to support why, you know, we chose that scenario, and then the others that didn't. So with the only evidence being that it eliminated the retrospective patterns. So so when you're working in that type of space in terms of what evidence, what lines of evidence there are to have this OM, you know, that is a difficult question sometimes to confront.
So you, Quang, you gave the example of Pacific halibut, and there were long-standing retrospective patterns once they started to investigate. Just as it's a really important case study, but what was it ever resolved? What the cause of the retrospective pattern was there?
Yes, I believe in the 90s, it was an issue of age versus length selectivity. So the earlier models from the 90s was modeling selectivity as an age-based function, which wasn't the best way to do it because the fleets were fishing in one area and the animals were doing something else. And so that's why you were getting the retrospective behavior. So once they switched to length selectivity, the retrospective pattern was a lot better, but then almost immediately a new set of issues came up again. So, you know, Pacific halibut is an interesting case study because they have all these data, but you can still screw up an assessment model because if you can't get everything right, then you still have this perverse behavior.
Carl had the advice of maybe going to simpler stock assessment models. Have you seen any evidence that such retrospective patterns will not appear so badly in simpler models, or could it be easily there's no way to adjust a simpler model to get your way out of a retrospective pattern?
I guess the question would be, you know, I think with a simpler model, you might have a bias in the model because of simpler assumptions, but those can be robust to your management objectives, right? So I think that's the first thing that comes to mind. And with a simpler model, I mean, you could just not have retrospective patterns because you're not trying to control as many things in there. It's yeah.
You actually showed that where that comparison across models. Didn't you have a bunch of surplus production model fits the ASAP thing compared to VPA, and they were the retrospective, that Moan thing was smaller for the.
Yeah, those are different stocks. Let's see what here.
That thing there, yeah. So
ACE, yeah.
is an ASAP a surplus production model?
No, it's a statistical catch at age.
Oh, is it? Okay.
Yeah.
Okay.
VPA, right to the VPA. But I think there was an assessment that used a surplus production model in New England that was rejected because of the retrospectives as well. I think it was for vertebrate or something like that. Maybe it was squid or something.
Yeah. No, it doesn't. It sure doesn't help with something like halibut, where you've had all these changes in growth and selectivity, size, structure, as Quang mentioned.
Mm-hmm.
Robin had some comments in the chat, so I don't know if Robin wanted to speak up.
Can you hear me?
Yep.
Oh, it was just a comment that, yeah, they did resolve that time varying, that retrospective pattern when they moved to time varying selectivity. Quite a few years ago now. That was when Steve Martell was at the Halibut Commission. Whether it was the actual cause is another question. It is a complex stock with a lot of movement, but that's I think what they settled on last time I looked.
Go ahead, Tom.
So one of the interesting things about MSE is that it can turn into this colossal dog and pony show, right? Of people deciding operating models and proposing MPs and performance metrics, and the whole thing can go on for years and years and years. It gets really complicated, and at the end of this whole thing, they choose an MP, like some algorithm for setting management advice. That's how they establish them. To reject them, they just plot the posterior predicted data from the MSE, and they see whether their data match up. I mean, it's ridiculous. The asymmetry in the rigor and complexity is crazy. And a missed opportunity is this idea that if you look at your robustness and reference operating models, a bit like Quang has done, is, let's say Carl's right, and you've got really bad hyperstability. The data that come out that you actually see can be quite indicative of that situation. So rather than just saying, well, look, do our data look like our operating models? You can say, do our data look like our problematic operating models? So in the case of hyperstability, the index doesn't decline very much, but mean length might, for example, or something similar. And so you can actually use the data to actively say we are under conditions, or we're in the parts of our simulation space. The data are consistent with parts of our simulation space where we know our MP doesn't work. And we don't do that in MSE. It's amazing. It's not done, and it's totally a missed opportunity. And it's part of what Quang's doing with these indicators. He's trying to work out whether or not we can actually identify the problematic situations. Because ultimately, it's very possible to have mission impossible operating models. So you need to know when you're in those situations, and that the MP you've chosen is just not going to work. Anyway, it was just a comment on those indicators.
Yeah, I was worried that maybe the indicator analysis could be very convoluted as well, because you can have high catch rates because you have an abundant stock or hyperstability, but then you'll have to look at covariance with another set of indicators to kind of narrow your operating models.
So it's now winding down to about 10:30. So are there any other questions at the moment? Comments? Don't see any. So, well, thank you very much, Quang, for a really excellent talk, great seminar. And thanks everybody for participating. Thanks to those of you who provided questions and comments. So thanks again. And I'll be in touch soon about our next week's speaker. I think it's William Chung. I have to double check. Okay. So thanks again. And there's a recording as well that will be available in case there are other people who want to see this who couldn't make it. So see you next week.